Quantum mechanics. Just hearing those words probably makes you think of all sorts of paradoxes and mysteries, things that just break your brain a little. But what if all that strangeness, all that famous weirdness, is really just a case of mistaken identity? What if the universe isn't the one that's confused, but we are? For almost 100 years, the story has been that the quantum world plays by these totally bizarre rules, completely alien to our everyday lives. But we're going to explore a really radical idea, drawing on the work of Rochelle Forrester. What if quantum mechanics isn't the weird one? What if it's been holding up a mirror to our own reality this whole time, and we've just been looking at it all wrong? Okay, so to really get what I'm talking about, we have to start with the mystery itself. Let's do a quick refresher on why the quantum realm has this reputation for being so unexplainably, well, weird. It all kind of kicks off with things like the famous double-slit experiment. So you shoot single particles, say photons, at a screen with two slits in it. And what happens seems impossible. Each individual photon acts like it went through both slits at the exact same time, interfering with itself and creating a wave pattern on the other side. I mean, how can one thing be in two places at once? It just shouldn't work that way. And this is where things get really strange. When we aren't looking, the photon is this spread-out wave, making that interference pattern. But, and get this, the second we put a little detector by the slits to see which way it went, poof, the wave behavior is gone. It snaps back to being a nice, simple particle going through one slit or the other. It's like the universe knows we're watching and forces the particle to pick a side. So, this gets right to the heart of the problem. It's not just that looking at something changes it. The standard thinking is that before we look, the particle doesn't even have a definite location. It's just a cloud of possibilities, a haze of probabilities. And our measurement is what literally snaps it into a single concrete reality. And believe it or not, this whole idea gets even crazier when you scale it up. I'm talking about the famous thought experiment, Schrödinger's cat. You put a cat in a box, and its life is tied to a random quantum event. The theory says that until you open that box and look, the cat isn't alive and it isn't dead. It's in a superposition of both states at the same time, which, let's be honest, is not how cats work in our world, right? Now, this weirdness is so deep, so profound, that physicists have come up with some truly mind-bending theories to try and make sense of it. As the source material we're looking at says, all these explanations have this aura of desperation about them. I mean, take a look at some of these ideas. You've got the many worlds interpretation, which says that when you look in that cat box, the entire universe splits in two. One where the cat is alive, and a whole new parallel universe where it's not. Or another one, the transactional interpretation, which involves waves traveling backwards in time to decide what happens. Right? You can kind of see why people say these are pretty desperate answers. Okay, but what if there's a huge plot twist here? What if the problem isn't that the quantum world is bizarre? What if the problem is that our whole common sense view of our own world is just plain wrong? All right, let's just forget about quantum physics for a second and think about this flower. To us, it's yellow. Simple enough. But a bee sees in ultraviolet light. To it, that same flower has these complex patterns we can't even begin to imagine. So, who's right? You? The bee? What color is that flower really? Well, the argument here from our source is that there is no real color. The yellow we see is just the result of light interacting with our eyes and our brain. The bee's ultraviolet pattern is the result of that same light interacting with its eyes. Both are totally valid. And that leads to a pretty mind-blowing conclusion. What we call reality is fundamentally dependent on who's doing the observing. Okay, I know what you're probably thinking. Wait a minute, I can close my eyes, open them again, and the tree outside my window is still there. It's consistent. And yeah, you're right, it is. But as the source points out, that consistency doesn't prove the tree exists on its own. It just means that beings with similar senses, like you, and you a second later, will build a similar reality. It works perfectly fine in a world that depends on an observer. So what does all this have to do with the quantum world? How do we build a bridge from a bee looking at a flower to a particle being in two places at once? Well, the key is something called the Copenhagen Interpretation. This is basically the standard textbook explanation for how quantum mechanics works, and its core idea is exactly what we've been talking about, that a quantum system, like a particle, doesn't actually have definite properties, like a specific position, until you measure it. The act of observation is what brings it into being. So now, let's put these two ideas side by side. It's pretty amazing. In our big, everyday world, from this new viewpoint, things like color and shape are created by our senses when we observe them. In the quantum world, things like spin and position are created by a measurement when we observe them. It's the exact same rule. That whole wave-particle duality thing, it's not some unique quantum strangeness. It's just what perceptual relativity looks like on a tiny, tiny scale. And just like that, poof, the whole measurement problem, this huge puzzle in physics about how looking at something creates reality, it just kind of dissolves. It's not a special quantum problem. It's a feature of all of reality. From cats to quarks, the world seems to follow the exact same observer-dependent rules. And getting your head around this isn't just a cool thought experiment. It's a complete revolution in how we see reality itself. Kind of like the other huge shifts we've seen throughout the history of science. We've been here before. Common sense used to tell us the Earth was flat and that everything revolved around us. Whoops, science showed us that was wrong. Common sense told us time and space were absolute and fixed. Then Einstein came along. So maybe, just maybe, our deepest gut feeling that reality is just out there, independent of us, is the next big, common sense idea that's about to get turned on its head. And really, that's the big takeaway here. Quantum mechanics isn't weird because it's different. It feels weird because it's been showing us how our own world actually works all along, and we just didn't realize it. We were looking at the reflection and calling it strange, without ever recognizing our own face.
Which leaves us with one last, kind of spooky question to chew on. If the solid, real, tangible world you see only snaps into existence when you look at it, then what, if anything, is really out there when nobody's looking?